Alright, so let's continue with a few more practical tips. These are small things, but in DS, small things create big differences in accuracy and time. So pay attention to the nuances that I discuss on this slide. And the first thing I discuss will be interesting because so far you've heard me say absolute numbers are not important. You should avoid answer choices with absolute numbers. However, here is the exception. If the question is asking you for an absolute value of something, then one of the statements does need to provide you with an actual number. So if you go back to the previous videos where I've said avoid absolute values, remember in all those questions, the question was not asking you for a unique number, it was asking you for some relation or some percentage. But if the question does ask you for an absolute number, what was John's salary in a particular year, then one of the two statements needs to give you an absolute number. If they just give you relationships, that won't suffice. So here's the question. It says how many members of a certain legislature voted against the measure to raise their salaries. Now the question is how many members. It's not a yes no type question, it's a value question. So now if I look at the two statements, so we've got our AD, BC, E. The first statement says 1/4 of the members of the legislature did not vote on the measure. Tells me nothing. So A and D are definitely out, because I don't get any absolute number anywhere in the first statement. Second statement says if 5 additional members of the legislature had voted against the measure, then the fraction of members of the legislature voting against the measure would have been 1/3. I'll say it at least sounds complicated, though if I was in a hurry, I would have marked E for this question and moved on, because I need an absolute number which is not there. This 5 most likely will not be of much use. But now, since we have time, let me do it slowly for you. We will try making an equation. So let's say the total number of members is Y. Okay, how many members of a certain legislature voted against the measure? So voted against, let's take that as X. And I'm combining the two statements because there is no way individually we are going to get the answer. But the first statement is pretty useless because it says 1/4 of the members did not vote. Keep in mind, it does not say they voted against. It says they did not vote, which means the number who voted was 3/4Y. Out of 3/4Y, some voted in favor, some voted against. X is the one that I've taken against. Let's see the second statement. If 5 additional members of the legislature had voted against the measure, so that would be X plus 5. Then the fraction of members of the legislature voting against the measure. So X plus 5 divided by total number of members, which is Y, would have been 1/3. So what will happen? I will get an equation with two variables, which I again will not be able to solve. I don't have enough information. So the answer will be E for this question. As I said, if I was in a hurry, I wouldn't have wasted time doing all of this. If the question is asking you for a value of something, then one of the two statements does need to provide you some absolute value. So use those absolute numbers to your advantage. I've shown you both the cases, when they will not be of use and when they will be very, very important. So what's the next thing? Less than, more than type questions touch the boundaries. What do I mean by that? I'll show you a couple of examples. In fact, let me also look at the next point because they are kind of similar or overlapping. Second point says if one of the statements says something is greater, less than X, do your calculation for that number itself, the boundary number. What do I mean by all this? Let me again show you a question. So the question says during a certain bicycle ride, was Sherry's average speed faster than 24 kilometers per hour? So the question is faster than 24 kilometers. I will do my calculation for 24 kilometer itself. That's the boundary value, not for something greater than that. So I've got my AD and BCE, and I'm not doing any pre-thinking because right now I can't think of any pre-thinking. The first statement says Sherry's average speed during the bicycle ride was faster than 7 meters per second. Now I know what pre-thinking is required because this is meters per second. Our question was kilometers per hour. So how do I convert? Because sometimes people get confused with the conversion. That's math, but simple. Go step by step. So 24 kilometers, which means how many meters they've told you, but I'm sure you already know that. That is 24,000 meters. And 24,000 meters in 60 minutes. How many seconds in 60 minutes? 60 into 60, right? So this needs to be divided by 60 into 60, and that will give you meters per second. So you don't need to remember any complicated formulas. Just use common sense. So 0 goes away, 0 goes away, 6 40 times. So 40 divided by 6. And since I have a calculator, I will use it. That's 6.6. 6.67. So the question is now, was Shari's average speed faster than 6.67 meters per second? The moment I've done that pre-solving, I know the first statement has to be sufficient because her average speed was faster than 7 meters, so definitely greater than 6.67. So BCE are out. Second statement says her average speed was slower than 8 meters. Not sufficient because it could be 6 meters per second or it could be 7 meters per second. So the second statement definitely does not work. A will be the answer. So even though the question says faster than 24 kilometers per hour, I did my calculation for 24 kilometers per hour, not for 24.1 kilometer or 24.5 kilometer or 25 kilometers, because people love to think in terms of integers. That's a waste of time. I'll show you one more question of this type. Here you go. So the question says, was the number of books sold at bookstore X last week greater than the number of books sold at bookstore Y last week? So it's a yes/no type question, not an absolute value question. So we have bookstore X and bookstore Y. Okay. First statement says, and we've got our AD, BCE. Never forget the process. First statement says, last week, more than 1,000 books were sold at bookstore X on Saturday. The question was for the entire week. So first statement talks about Saturday. Okay. Bookstore X, more than 1,000 books. So 1,000 plus. And fewer than 1,000 at bookstore Y. So 1,000 minus. Okay, definitely not sufficient because we have no idea what happened on the other days of the week. So A and D are out. Second statement says, last week, less than 20% of the books sold at bookstore X were sold on Saturday, and more than 20% of the books sold at bookstore Y were sold on Saturday. Definitely not going to be sufficient by itself, so B is also out. So I know it will either be combined or I won't get the answer at all. So let me put that information also. Now I'm combining the statements. So last week, less than 20% of the books sold at bookstore X were sold on Saturday. So this number is less than 20% of the total number. And if you're reasonably decent at percentages, see, 20% is nothing but 1/5. So what does this actually mean in terms of math? Keep in mind the number of books is greater than 1,000. Let's treat it as 1,000 only. So then the total sales of bookstore X will be what? 5,000. If this was exactly 20%, it would be 5,000. But we know it will be more than that because one, this number is greater than 1,000 and that is less than 20%. So understand again, the total number of books would have been 5 times if this was exactly equal to 20%. Less than 20% means the total number will be actually more than 5 times. But I won't confuse myself with all that. I will work with these very numbers, which is why what I said on the slide. Work with the boundary values. Don't treat this as 1001 or 1100 or 1010. Why confuse yourself? You know what's happening. You know this number is actually greater than 1,000. And you know it is less than 20%. So when I do the calculation exactly for 20% and 1,000, the total number of books sold comes to 5,000. So I know this has to actually be greater than 5,000. That's the common sense part. Now come to bookstore Y, where this number is more than 20% of the total. So now whatever happened in this case, the opposite will happen over there. So 1,000 times 5, I'm again doing the same calculation. I'm treating this as 1,000, treating this as 20%. So it again comes to 5,000, but I know this will actually be less than 5,000 because this number is less than 1,000 and this is actually more than 20%. So if something is more than 20% means the total will be less than 5 times of that. That is the percentage clarity you want to have in mind. So wherever you've done your quant from, I hope you've got that clarity because percentages is a very, very important topic. You don't want to just use the math to calculate percentages. You want to be good at this kind of mental stuff. So while the number is 5,000 in both the cases as per the calculation, but as per my understanding which I've explained to you, for bookstore X, the number of books will be greater than 5,000. For bookstore Y, the number will be less than 5,000. So I'm getting a unique answer. I know X has sold more books than Y has sold. So C will be the answer to that question. It's a good tricky question. The takeaway for you, if they give you boundary values like 1,000, 20%, use those very values, don't change them. And then when you get the final number, that's where you use your understanding of whether you want to go higher than the boundary, lower than the boundary, make that adjustment in your head. So what's the next thing? Persons without base value are of no use. It's a very common trap actually. So if you see something has increased by 20%, you will think, great, I have all the information I need. But 20% of what? You need that base value, right? If a salary increases by 20%, I have no idea how much it has increased by. If the original salary was $100, it's increased by $20. But if the original salary was $10,000, it has increased by $2,000. Completely different values. Let me again show you a question for this. So the question says the total profit of corporation K was 3.4 million in year X. What was the total profit in year Y? So I need some relation between the profit of year Y and the profit of year X to be able to get to the answer. And I also know that profit is nothing but revenue minus cost or expenses, whatever. So we've got our AD and BCE. Let's look at statement 1. Income in year Y was 30% more than in year X. But I have no idea what was the income in year X in any case. So definitely not sufficient. Income is same thing as revenues, by the way. Second statement says cost in year Y were 40% more than in year X. Let's see what will happen on this question is, this is that question that I have discussed with you earlier where you will be quickly down to C and E. It has to be one of those because you need income and cost more to get to the answer because profit is nothing but income minus cost. And in this case, the answer will be E because you have no base value for income or cost given to you. Income can be $1 million, cost can be $10. Or income can be $1 million, cost can be $1 less than that. And the answer will change then. So percentages are of no use unless there is some base value also given to you in these value type questions where it's not a yes no question. So the next thing is watch the language like a hawk on those weird English questions. There a lot of those weird questions are critical reasoning questions. They confuse you with the language. So be very, very careful. Let me give you an example of what I mean. So the question is, what is the limiting factor when it comes to us using the most effective solution? A very weird question, as you can see. I'm not doing any pre-thinking. I'm just going to the first statement. We have identified several potential solutions, but a lack of funding hinders their implementation. And it's a tricky option because lack of funding definitely looks like a limiting factor. But the question is limiting factor for the most effective solution. Now, we have identified several solutions. I have no idea if one of them includes the most effective one. So while it looks very, very tempting, A will be out, which means D will also be out. Second statement says, as the most effective solution requires extensive resources, so most effective does come into the picture, we must opt for a more affordable option given our budget. And that is sufficient because one, we know we're talking about the most effective and we know the constraint is budget or resource availability. So B becomes your answer. But I'm absolutely sure this D will be a very, very popular answer for this question. Incidentally, I hope you guys are trying these questions once by yourself before looking at my explanation to them. If you haven't, please start doing so. Try it once by yourself, pause the video, and then come back and see whether you got it correct and how I am approaching the question. Don't just watch these passively. Okay, next thing, read the question very carefully. I know I've said this before, but I'll say it again because this is where a lot of points are lost. Students skim, they assume things, they rush through things, and then they end up misinterpreting the task. So slow down just enough to understand what is being asked of you. Let's look at another question. Yeah, this question that we've already discussed earlier in one of the videos. Was the amount of John's heating bill for February greater than it was for January? So the first thing, we know it's a yes-no question. We don't have to find an actual value. If you don't have to find an actual value, you don't need the absolute value. So while if you look at the two statements, you would be very, very tempted to go with C, but the answer will actually be A. We've discussed this earlier, so I'm not doing it again. But A will be sufficient because if the ratio is 26 upon 25, we know that the amount of the heating bill for February is greater than it is for January. How much it is, nobody cares. So I don't need the second statement. So read the question very, very carefully as to what is being asked. Finally, the last thing, sometimes calculation will be necessary. As I was saying earlier, some questions will be time taking, and on some questions you will have to do calculations, make equations. So do so. And again, whether you need to do that or not will be a function of how you are performing in your mocks. If you're scoring 655, 675 or higher, then you will get some questions where you will have to do the calculations. But if you're scoring in the 500s in the mocks, 575, 585, 615, then if you're doing too many calculations on DS, you're making a mistake. That's something related to test taking strategy that I will discuss a little in the last video of this course. So let me show you one question though, where you may have to do calculations. So here's the question. A company produces a certain toy in only two sizes, small or large, and in only two colors, red or green. So I won't just keep reading it because then it will get overwhelming. I always put down stuff. That's my pre-thinking, pre-solving. So I'm getting two sizes and two colors. So let's say I'll say small, large, and two colors. What are the two colors? Red. So I've actually made a grid like you do on those 4 variable sets questions, because this will make it easier for me to visualize what I'm doing. So okay, and then it says if for each size there are equal number of red and green toys in a certain production lot. What does that mean? For each size, let's say small size, there are equal number of red and green. So if this is X, this is also X. And same thing over here, if this is Y, this is also Y, which is also giving me totals, keep in mind. So total red becomes X plus Y. I don't know if this will be useful, I'm just putting it down. Total green becomes X plus Y. Total small becomes 2X. Total large becomes 2Y. So all this is still my pre-work. What is the question? What fraction of the total number of green toys, total number of green was X plus Y, is large? So my question is, what is Y? Because Y is large green toys divided by X plus Y. This is my question. I am not being asked for an absolute number, I'm being asked for a fraction. And I look at statement 1, so this is my AD, BCE. In this case, of course, statement 1 is of no use. In the production lot, 400 of the small toys are green. That just tells you the value of X. From there, I can't infer anything about Y. So that is not going to be sufficient. And not only is it not going to be sufficient, but if you've paid attention to all that I've taught so far, you know most likely that will not even be required to get to the answer. The answer will either be B or it will be E. Most likely, of course. Because if you start thinking that that absolute number is relevant, you will end up subconsciously combining that with statement 2, or when you look at statement 2, you won't evaluate it properly because you will be tempted to mix it up because you think the absolute number is very important when it is not. Why is it not? Because nobody is asking us for an exact number in the question. It's just a fraction. Second statement, in the production lot, 2/3 of the toys produced are small. What does that tell me? So what is the total toys produced? Total toys produced is 2X plus 2Y, right? And it says 2/3 of this is small, and small is this number, right? 2X. So you see, had I not written, I would have never been able to arrive at this equation. This will take us somewhere, I think. Let me do the cross multiplication and see where we are going with this. So I have little less space over here. So let's see, 4X plus 4Y is equal to 6X. See, it's going to give us a relation between X and Y. So this becomes 2X is equal to 4Y or X is equal to 2Y. And now see, you got your answer, right? Because our question was this. Now I can replace this X with 2Y and I get the answer as Y divided by, so this becomes Y divided by 3Y, Y gets cancelled, the fraction is 1/3. So statement 2 is giving me the answer, but I had to go all the way till the end. Had I been in a hurry, I honestly would have picked between B and E as I showed you why, and start using all of that when you start doing questions, because that's the kind of practical common sense approach that you need to adopt for the entire GMAT, not just for data sufficiency. You will see me do that on the other question types in DI, and you should also do that for quant and English as well. Think like a smart manager, not like a student. The GMAT is not an academic test. It's a test of business skills, managerial skills actually. So the answer is B, of course, for this question. So if I have to summarize, I'd say DS is not about one big idea. It's about many small decisions done right. Decisions, that's the key word. Go back to my first video. So get these small things right and your overall performance improves significantly. On the next slide, I will focus specifically on some 705 plus questions similar to the one you saw, so you understand how I would approach those questions and you start adopting some of those tricks or techniques in your practice as well. So I'll see you in that video.